What do you mean by internal and external views? Right? What do you mean by internal and external views? Okay, I'll give you an example for this. The example is, say for example, you have a washing machine, right? You have purchased a washing machine, and what you are doing is that, okay, this is a new washing machine, so you started testing it. Testing in the sense you're checking whether it serves your purpose, right? So you put on the clothes, right? Enough water will be filled, and then you will start washing it, and then fine, checking it whether it is properly working or not. Fine, okay. If it is working well, no issues. Okay. Now, another case, you are washing the clothes, you are checking whether it is working or not. It's not working. Say for example, it is not rinsing, for example. So it means that some error is there. So what you will do, you will call the technician. The technician will come and he will check. Okay, okay, some error is there, some malfunction is there. So he will open the washing machine and he'll check, okay, what is there the problem, and then he will rectify it, and then he'll go, right? The first you did, right? The first you did is called as external view of testing. That is, you have bought a washing machine, and what you did, you simply tested, right? And it is working fine. So that is the external view. And what happens if any issue is there? Okay, some issue is there, but you don't know what has happened inside. You don't know what has happened inside. That is what external view of testing, right? So for that, what you will require, how to operate the washing machine. That is what, right? How to operate the washing machine, right? That is what you call as the external view of it. Internal view means what? Internal views, the technician came, right? He checked the external part first, and then he checked the internal part, because to rectify the issue. Is it right? That is why he is opening the washing machine and he's checking it. And that is what is called as internal view of testing. So I think you can able to compare the external views and internal view. External views means what? You may be knowing only the specific function. That function will be tested and check that whether the function is correctly operating or not. That is what is called as the external views, right? And internal views means whether for that functionality, what is the logical thing happening inside? Is there any issue in that, right? That is what we call as the internal view of testing, right? So there are two types of testing: white box testing and black box testing, right? White box testing means what? Internal views. Internal view example is white box testing. Black box testing is also called as external views, right? That is, the external views example is black box testing, right? So in the interview, if you are going for a testing interview, right? Even if you are going for a development interview, right? They will ask this question. It will be a sure question, right? I'll write and give it to you. Okay. What do you mean by white box testing? What do you mean by black box testing, right? You have to. Okay, let us discuss in detail. Don't worry. Test case design. So the design should be, the objective of the test case should uncover the error. That is, you have to identify the error, right? That is the objective. Criteria is you have to complete it in a complete manner. Everything should be completed. Every test cases should be completed. That is what the criteria. Constraint. As early as possible, you have to identify the errors. That is, constraint is with the minimum of effort and time, right? That is what we have discussed till now. The test case design should uncover the error, should complete, the test should be complete, and with minimum effort and time. These are the three major characteristics or three major objective of test case design, right? Fine. Okay. You are seeing a flow chart, is it right? You are seeing a flow chart. So from this flow chart, can you tell me how many test cases are required for completing the test? Because this is one, this is for, say, a conditional statement. Sorry, not conditional statement. This is for a assigned statement, right? And this is a condition. This is another condition. This is another condition. Condition, statement, condition. Fine. right? So can you please tell me how many test cases required to write it? I'll tell you one example, and then you count it and tell me. One example is I'll be testing this path, right? And this is yes and this is no, for example. Then I'll select this yes path and this yes path, this yes path. So you come here, right? And this yes path, fine. But this is one path. So this you can call it as one test case. So starting to end, it is a complete test case, right? Starting to end, right? So like this, how many tests are there? Can you please tell me? So can you please tell me how many tests are there? So one path I shown you. What will be the next path? So here it will come here, right? It will come here, and so it will come another path. It will come here. It will come here. Fine, right? So I selected one more path, second path. This is another test case. The third test case is this come here, right? And I am going in this path, right? And then I am coming here, and coming here, and coming here. This is one path, right? Likewise, so what I am trying to say here is that if you are taking a test case, right, and the path should complete it. That is what, right? The criteria I told you, it is in a complete manner. If you are taking a path, it should complete it, right? So for this, you will be able to identify how many number of paths it's there that you can able to identify, right? This is what is called as exhaustive testing. You should not leave any statements, right? You should not miss any of the path. Every path you have to take, right? Okay, that is what is called as exhaustive testing. The selective testing means you will be selecting only the required path. This is what you will be selecting, only this path. This is the selected path, right? This is called as selective testing, right? Fine. So now let us move on to the next part, white box methods and black box methods, right? So first we should discuss about what is white box testing, right? So white box testing means what is happening inside. What is the logical way of testing a particular product, right? Right. So that is what we call it as what is that? White box testing. You are testing inside a particular component, right? So our goal is to ensure that the statements and conditions have been executed at least once. See, all these are, say for example, this is one statement, 2, 3, 4, 5, 6 statements are there, right? So you are selecting this path. You are selecting this path, right? So this is one test case. It doesn't mean that you have successfully completed the testing. No, right? Only one test cases you have done, and this condition is missed, right? This condition is missed. So then you have to go this path. So 2 path you have selected, right? 2 path you have selected. So if you are selecting this 2 path, then you can assure that complete testing is done. That is what is called as the white box testing. Our goal is to ensure that all statements and conditions, right, should be executed at least once, right? At least once. If you have this condition, if you have this in your mind, then you will be able to identify easily the errors, right? Every statement should be executed at least once. That is called as white box testing, right? Basis path testing is a white box testing first proposed by Tom McCabe. So we are going to discuss about basis path testing, right? Once we discuss this, we'll wind up the class, right? Very important. Please listen carefully. Very important, because in the book it is totally confused, right? They have written very well, right? They have written very well, but it's totally confused, right? It's difficult to understand. That is why I made it very simple. Listen carefully. Okay. So what is the basis path testing? The basis path testing method enables a test case designer to derive logical complexity measure of a procedural design and use this measure as a guide of defining a basis set of execution paths, right? So this test case, what he is doing, right? He is deriving a logical complexity measure. Why he is deriving that? To identify the set of execution paths. Right, I'll tell you what is the first step. He is measuring, he is deriving a logical complexity measure. Why he is doing that? For defining a set of execution paths. So what are the execution paths? Right? He is defining that. And he is guaranteeing that every statement is executed. That is why it is a white box testing. Basis path testing is a white box testing. Okay. So you should guarantee that the tester should guarantee that every statement should be executed. Okay. This is what is the basis path testing. There are 4 steps, right, for doing the basis path testing. Design control flow graph. First, right, if you have the software with you, if you have the software with you, right, if you are going to test a software, the first step you are going to do is that design control flow graph. You are designing a graph and then finding or calculating the cyclomatic complexity, or identifying the or calculating the cyclomatic complexity. And then what you're doing is that you are generating set of paths. You are generating set of paths. And then finally, you are testing each path. So for example, generating a set of path means what? That is what your test case. Okay, you'll generate a list of paths, a set of paths, and each path should be tested properly. That is why test each path. So these are the 4 major steps in basis path testing. Let us see one by one in detail. I'll take one very simple example, right? And this is actually available in the internet, right? I have taken that material directly, and it's a very simple school level problem or a coding, right? I mean algorithm, right? So let us analyze our testing with this particular algorithm. So what is the step 1, right? It is actually a triangle problem, right? You are going to identify what triangle it is, whether it is a equilateral triangle or a isosceles triangle or a scalene triangle, or it is not a triangle. So these 4 conditions you are testing. That is the triangle problem. Okay. As a first step, what you are doing is that you are inputting value A, B, and C, which should greater than 0, right? You are getting the values A, B, and C, and you are checking this condition. You are checking this condition, right? If the condition satisfies, then it is not a triangle. If the condition doesn't satisfy, right, you go to the else part. In the else part, it is checking whether A is equal to B and A is equal to C. Then it is a equilateral triangle, right? So equilateral triangle, fine, yeah, equilateral triangle. And then else if A is equal to B or A is equal to C or B is equal to C, then it is going to be an isosceles triangle, right? Else it is a scalene triangle. So this is what the condition. Don't need to worry about the code, right? I mean the algorithm, right? Don't worry about it. We have to check whether we are able to test it properly, right? First is you have to calculate the control flow graph, right? So this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is you can call it as the steps. Call it as the steps, right? Okay. In algorithm wise, it is steps. In control flow graph, right? It is going to be the nodes. This 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All are nodes. Okay. Excellent. Okay. So now, what is the first step we have discussed? You are inputting. You are inputting, right, 3 values A, B, and C. Then you are checking the condition. And then output is not a triangle, right? If the condition satisfies, output is not a triangle, then that's it. You'll go to the 4th step. So 1, 2, 3, and 10. This is the first control flow, right? 1, 2, 3, and 10. This is the first control flow path. Is it right? The second is, right? Likewise, you can able to identify the path of it. Is it right? Okay, fine. Let us discuss that in detail. So control flow graph means what? Based on the branches and based on the algorithm, you are creating the control flow graph. Each nodes are called as the steps here you are having, and connecting these nodes, right? It is called as the edges all these are edges. All these are edges. So let me do one thing. Let me identify the or calculate the cyclomatic complexity, right? What I told, these all are nodes, right? And these all are edges. Connecting the node side is the edges, right? So let me count the edges: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 edges are there, right? And 10 nodes are there. And for calculating the cyclomatic complex, this is the formula. Cc is equal to E minus N plus 2. E is edges, N is nodes, right? So substitute the values. 12 minus 10 plus 2 is equal to 4. So you will be getting 4 paths. You will be getting 4 paths, right? Let us verify whether it is correct or not, right? This is one path, this is another path, this is another path, this is another path. 4 paths are there. This is what, this is how you have calculated the cyclomatic complexity. Let us check it whether it is working or not. So this is the first path. Step 1, 2, 3, and 4. That is, input your values, check this condition. If it satisfies, it is getting the output and then returning output. This is the first branch. So the cyclomatic path is, the triangle path is 1, 2, 3, and 10. What about the next one? 1, 2, 3, sorry, 1, 2, 4, 5, and 10. So you are getting the input, checking the condition. If it is not, if the condition doesn't satisfy, then we'll go to the next else if. If this condition satisfies, then you'll go to this output and you'll return the output. So 1, 2, 4, 5, and 10, right? Then the third one is isosceles triangle path, right? Step 1, step 2, step 4, step 6, step 7, step 10, right? Fine. So in this case, this is the path. What about the next step? Scalene triangle test path, right? So for that, this is the path. So now, from this, you can able to conclude that at least one, every statement is executing at least once. That is a requirement, right? Every statement, the basis path testing, what is the thing, right? Basis set are guaranteed to execute every statement at least one time. At least one time. So these paths are executed. These nodes are the conditions, right? Statements. So these nodes are executed at least once. Likewise, we have to generate the path. That is why 1, 2, 3, 4 paths are there. So if we calculate the cyclomatic complexity, we will be able to identify how many number of paths are available, right? Then we have to identify the exact path of it. 1, 2, 3, 10. This is 1, 2, 4, 5, and 10. Likewise, right? And then we can come to a conclusion that, okay, this particular number of paths is actually, what is that? Identifying all the paths. So it is calculating all the, or executing all the statements at least once, right? So then you will be able to identify the errors, right? So where the error is actually, that you can able to easily identify it. This is what is called as a basis path design.